Hello everyone, myself Ganavi, studying in Sri Venkateshwara College of Engineering from the Department of Computer Science. Today's topic is about performing the remote operations efficiently on a local computer networks. Abstract, a communication model is described that can serve as a basis for an highly efficient communication subsystem for local networks. The model contains a taxonomy of communication instructions that can be implemented efficiently and can be good basis for the interprocessor communication. Also, these communication instructions are called as remote references that causes an operations to be performed by the remote process and optionally. It also causes a value to be returned. And this also represents the implementation consideration for a communication system based upon the model and describes an experimental communication subsystems that provides on a class of remote references. These remote references take about 150 microseconds or 50 average instructions time to perform on Xerox Alto computers. Introduction. The goal is to reduce the processing overhead of network communication for distributed programs. The context is a high bandwidth, low latency network. Um, it focuses mainly on the communication subsystems for the language level primitives. The motivation of it is network is to it traditional networks communications overhead is high, approximately equals to 20 milliseconds. It also needed for efficient communications to enable the fine-grained parallelism. It is important for language level primitives like remote procedure cells. Purposed communication subsystems are integrated implementation approach, like which are versus layered approach. Implementation consideration, the techniques are for efficient implementation. It is important of a microcoded or specialized hardware. Remote reference or remote operational model. The overview of the model is like the remote reference or the remote operation model. It is used for like communications. It processes the executive remote references that causes remote operations. Remote operations may return the values to the callers. Key components are like master, slaves, remote references, and remote operations. Advantages of this model is utility of primitivity, support of reliability, potential for protocol simplification, potential for efficient implementation. Utility of primitives are like powerful primitives that reduces the software layering. Examples like remote memory references, subrouting calls, message passing, etc. It supports the efficient implementation of high-level primitives. Support for reliabilities are it is an end-to-end reliability for the high reliability transmission media. Remote references ensures that operation completion, and it is not only just for messaging delivery. Potential for protocol simplifications are the simpler protocols for specifying the remote references. It reduces the complexity compared to the general communication mechanisms. Potential for efficient implementation, it specializes the implementation in microcode or hardware. It is efficient in execution of remote references. Definition and assumptions. System architectures are the process connected by the local network. It has high bandwidth, low latency, and high reliability, and also the low cost. Local network properties are like packets eventually reach destinations with enough transmissions. The corrupted packets are discarded. There is no duplicated packets, and the packets arrived in the order. Failure models are processor fails detachably and are restarted. There are two types of processor. One is regular processor which disappears after the failure. Another one is a recoverable process which is reconcatenated or after the failure. Communication process, coverable process. It is implemented for rapid activations. The function of communication processor. packet transmission or replications, communication state information manipulation, execution of communication primitives, and the execution of simple remote operations. Model description: sequence of actions are reference committee, on being commit, of, of end commit, and result commit. Actions of properties are atomicity and reliability. Protocol variation simple. The master sends the request packet, waits for the response packet. The multiple packets, error handling, and the retries are complex in model description. Key components are like master, slaves, and the communication process. A reference taxonomy, attribute class descriptions. Reliability schematic defines the level of reliability for the remote references. Return values specifies whether a value is returned to the master, example like synchronous, asynchronous. Temporary relationship describes when the remote operation occurs relative to the reference. Flow control determines whether the flow control is required to prevent overloading. Examples like buffered, unbuffered. Process types identifies the types of process performing the remote operations like recoverable or regular. Failure scenarios are like communication failure, that are lost packets, slave processor failure, master processor failure. Only only once two type attributes are the appliances to reference to recoverable sleeves from recoverable or non-recoverable matters. It ensures exactly one operand end commit, regardless of failures. Result commits always occurs if master is recoverable. Values no values reference. Value reference explicitly returns a value to the master process. It applies to reference with the schematics other than the maybe. Returned value is provided by remote operations. It is provided by the communication systems. No value references do not return a value. Apply to maybe references. No response is required for reliability and efficient for operation producing no values. Synchronous classes. Three synchronous classes for remote operations are processor synchronous, and asynchronous. Processor synchronous are operations executed synchronously with respect to the calling processor. Process synchronous are the operations executed synchronously with respect to the calling process. Asynchronous are the operations executed asynchronously with respect to the calling processor. Order of completion independent of reference order. Inter-reference flow control. Synchronous. Processor synchronous reference. It is an efficient for short request response and quick remote operations. It is useful when remote operations cost is less than the additional overhead. Timeout and re-execution in process synchronous fashion is possible. Process synchronous reference, the next most efficient after process synchronous. There is no need for mastering to account for multiple outstanding requests. Less complex protocol than asynchronous reference. Asynchronous reference are more complex protocols due to multiple outstanding requests. The requirements of asynchronous references are: it needs a demultiplexing and queuing response, a request and response correlations. It also needs a potentially cost process switches. It is a flow controlled reference. Protocols. There are three types of protocols. One is R protocol, the second is RR protocol, and the third is RRA protocol. R protocol is a request protocol that is useful for maybe no value, not flow controlled references. It is a data encapsulated in request transmitted to slaves. RR is a request response protocol which is useful for many reference types and masters the initiative remote operations like slaves that returns results. It also requires a unique identifier for requesting the response matching. RRA is a requesting response acknowledged protocol that is useful for only once asynchronous reference. The slaves response acknowledged allowing the space reclaim. A sequence number requires for request response matching. An example only once type synchronous. Example overview. In this type of asynchronous, it is an value reference. We use it for remote references to write a page to secondary storage, and then unlock the page, and also and to return the version number. It uses a RR protocol. Implementation steps. First, the implementation steps in this examples are reference commit. A reference commit is a commit that masters the create the to suitable entry in the sockets with request and the sequence number n. The request transmitted to the slaves until the result commit occurs. Slave processing, it performs the requested operations like write page, unlock, case study overview. It implements the only once type 1 primary processor synchronous reference, the two implementation software and the microcode. It uses efficient synchronous protocols ESP. Xerox Alto computers with 2.94 megabyte Ethernet. Implementation's goals are: it illustrates the remote reference model terminology. It also demonstrates the direct implementation approach. It shows the performance statistics for the local networks. Software implementation: 5 subroutines for RLDA, RSTA, RCS, RENQ, requeuing, and the reading RDEQ references. It uses BCPL and PUP level 0 datagram facilities. Sessions maintained between the communication processor. Duplicating element via sequence number field. Microde implementations. Two separate microde sets are the masters and slaves. Microdes is similar to the software but with the optimizations, error handling, multitasking, and timeout simplified. It uses 280 instructions and 7 hardware registers, additional 728 words of main memory for the socket table. Architecture consideration, efficient remote references, hardware configurations are used like local networks that controls the integrations with processor for fine-grained communications. The communication process implementations on the network controller or the processor. The fast access to maintain the main processor memory requires the low latency, high bandwidth, stable storage necessary for only once type 2 references. If the network controllers should allow the receptions of back to back packets. Local network requirement, it needs a high bandwidth, examples like 100 megabytes. It supports for small packets length. It has a low latency, and it uses the ring type of network, example Cambridge TRWMIT, that is suitable for high speed requirements. Comparisons to the existing architectures, it shares the memory multiprocessor, which are more costly shared memory access. Conventional network based systems are the less efficient communication. Tandem non-stop systems are similar to the architecture. Summary: we present a communication model that includes a taxonomy of communication instructions called the remote references. The specialization of the references permits the efficient implementations, and the semantic attributes of the reference makes them a good basis for the constructions of distributed programs. Though relatively complete, the taxonomy could be extended to include the more complex types of sessions, such as those multi-slaves, and to include other semantic attributes such as intra-reference flow control for the reference having very variable size request and the response. Following is the discussion of the model. We presented issues that arises when the implementation of communication subsystems based upon the model. This experimental communication subsystem for the Alto shows that a streamlined system based upon the model can be implemented with a great efficiency. To demonstrate this further, the utility of the remote reference or remote operations model, A reasonable subset of the communication primitives must be selected, and a complete communication subsystems design. Not all references can be implemented as efficiently as those as an example, but without doubt they could be implemented much more efficiently than a normal communication. Thank you.